In this video, we'll introduce the concept of a function. As a starting point, we'll first discuss relations. A relation is a correspondence between two sets, a set of inputs or x values, and a set of outputs or y values. As an example, there is a relation between a congressperson and the state that congressperson represents in the U.S. House of Representatives. In this situation, the congressperson would be the input, and the state that is being represented would be the output. So the structure of this relation is I would give you the congressperson, and then you would tell me what state that person represents. As a second example, there is a relation between each state and the senators that serve in the U.S. Senate for that state. In this situation, the state is the input, and the senators are the outputs. This relation is structured in a way that I would start with giving you the state, and then you in turn would then give me the senators that serve for that state. A function, on the other hand, is a special type of relation. A function is a relation where each input, or x value, corresponds to exactly one output, or y value. In other words, a function is a correspondence between a set of inputs, called the domain, and a set of outputs, called the range, in which each input is paired with exactly one output. We can use the phrasing, the output is a function of the input, or we'll say, the y value is a function of the x value. Going back to the previous two examples, the relation between a congressperson and the state that congressperson represents in the House of Representatives is a function, as each congressperson or input can represent only one state at any given moment in time. The second example, the relation between each state and the senators that serve in the U.S. Senate for that state, is not a function. Each state, each input, has exactly two senators that represent that state. So in this situation, each input is not being paired with exactly one output. You can try to visualize a function as a vending machine. A vending machine is working when, for each button you push, you get exactly one thing out of the vending machine. If you push a single button and you get two different things out of the vending machine, while you might be happy, you will recognize the machine is broken. A broken vending machine is not a function. In this example, if you press A1, then you get a Snickers bar. If you press B1, then you get a Mars bar. If you press C1, then you'll get a Milky Way bar. And if you press D1, then you'll get a Scrumdiddlyumptious bar. Fully explain, referencing the formal definition of a function, why this is an example of a function. Well, the formal definition said for each input, there must be exactly one output. In this example, each vending machine button gives you exactly one candy bar. This is a function because each button corresponds or is paired with exactly one candy bar. If we now consider this vending machine, if you press A1, then you get a Snickers bar. If you press A1, then you get a Mars bar. If you press A1, then you get a Milky Way bar. And if you press A1, then you get a Scrumdiddlyumptious bar. Fully explain, referencing the formal definition of a function, why this is not an example of a function. In this particular example, a single input or button will now give you 4 candy bars. So this does not meet the definition of a single input is paired with exactly one output. The input of A1 will give you 4 separate outputs. To be a function, each input must be paired with exactly one output.